So that's kind of exciting. Thanks a lot, Robert, and everybody. You know, the last time I presented this group was probably about 6 years ago, believe it or not, at the very second user group meeting, where there was about, what, 12 people?
Yeah, I'm trying to bring it up a little bit.
Okay, thanks. So it's exciting to see how much this group has grown, and you know, I don't get to come to these meetings as much as I'd like to. I actually live down near Philadelphia, and I tend to turn into a pumpkin if I'm in New York City past 6 p.m. So I don't get to see it a lot, and this is really great to see everybody here, and let's get started. Everybody say a little prayer. Okay, it's working, great. All right, so quickly about me. You guys read everything about that. I'm a registered architect. I work at HOK right now. I was formerly at SOM. I was at SOM for about 4 years before spending 3 years here at HOK. Before that, I worked at a really small firm down in Philadelphia called J. Raymond Perry Architects, where I kind of learned about it. Been using Revit since version 1, so that's what, about 12, 13 years now. So it's been a long time using Revit. Those are just some of the projects I work on. I got a wife, there's my 2 kids, there's a puppy. I like motorsports, I drive a Mini, and I'm technically not the Stig, even though I think I am. Any Top Gear fans? No? All right, crickets, great. This is starting off well. All right, so this presentation really is going to be about, you know, we're going to get into the details of what the IFC file is, but we're not going to get into the schema and technical arrangements and how to program it and everything else. What we're really going to talk about is practical uses of the IFC that you can use right now. And all of the things you're going to see today, really Revit is kind of the core tool here. Obviously that's our core design authoring tool, but everything you see kind of comes in and out of Revit, either via IFC. So we'll start with the history. Initially, the actual file format itself is really technically Building Smart's data model, and it started way back in '94. It's actually in high school, so if you do the math, I guess I'm 27. And it started with the Alliance for Interoperability. Anybody have any idea who founded who was a major funder and founder of the Alliance for Interoperability?
Patrick McLean.
Yeah, well, that's good. That's good. Autodesk was actually the primary sponsor. We believe that or not. HOK was involved, so was Tishman. And a couple of industry experts like Honeywell, Carrier, and for some reason AT&T. I have no idea why, but they were initially involved, I guess designing phones. So anyway, skip ahead to '97. We kind of moved out and it became a nonprofit. Became an International Alliance for Interoperability, and it was industry-led. And then this is where they first published the IFC as kind of a neutral AEC product model, right? If you move even further ahead, a couple of years, back to up to 05, we start to get the actual file. Everything was developed, the schema, the file type, and et cetera. And now, currently it's at IFC 2x3. I'm not going to get details of what that means, but IFC 4, which is, I guess it's 2x4, but now we're calling it IFC 4. That's the next generation. There's actually massive improvements in that file format, and that's right now in a release candidate. So we're not going to go into details about what's different about it, but just know it's there and it's coming. All right, so let's look a little bit closer at the file format itself. Okay, well, what is it, right? Essentially, it's it's a standard for building information models, but not for drawings. This is a key point here. Doesn't deal with any kind of line weights, layering standards, anything like that. It just enables exchange of information about the building, whatever's in the building, the spaces, the objects, and anything else that can go into a building information model. So how does it start? Well, essentially, there's 3 parts to this. There's the information delivery manual, which is not a technical thing. It's not a piece of software. But what it is basically a definition about how an exchange between 2 parties is supposed to work. So this is kind of high-level stuff. We bring in architects, contractors, owners. Everybody talks about what needs to transfer between both parties and how it needs to transfer there. So the second part of that is what we call the model view definitions, and all that is, it really answers the question: what do you want to see? If you can imagine the IFC schema, it can contain anything you can possibly put in a building information model, right? It's down to analytical data, to operations and management data, design data, whatever. We don't all need all of that every time, right? So model view definitions help define exactly what subset of the schema is needed to satisfy that exchange requirement. In our case, the vast majority of you out there right now are probably using the coordination view. And the coordination view is simply, it really just kind of guarantees that geometry in software A will look like geometry in software B. That's all there is to it. It's not really too much more, and any information attached to those things. It has nothing to do with model-based coordination or clash detection or anything like that. Another popular view right now is the structural analysis view. So now we start to get analytical data, so you can get analytical model information from there. And of course, everyone's favorite is the FM handover view, which is obviously COBE, right? A lot of people think COBE is just Excel, just a spreadsheet, but it's actually not part of the IFC schema and can be an IFC file. Okay, so what's included in the IFC? Well, like I just said, it depends on the MVD, but generally you're going to get 3D and 2D geometry, any property and attributes attached to that geometry, parameters, and I think most importantly here is relationships and connectivity. So objects know what system they're in, they know what they're connected to, right? And that's kind of a key feature. That's it's much more advanced than just simple geometric translation. Okay. So let's look at some practical uses right now. And the way I've kind of divided this up is by BIM use. I don't know if you guys do project execution plans, things like that, but what we've done is, what I've done here is basically said, all right, we'll look at design authoring, we'll look at model-based coordination, we'll look at design collaboration, we'll look at performance-based design, and we'll look at how the IFC works within those. So first thing we're going to look at is one of the fun ones, I think, is design authoring. And there's a lot of things you can do with design authoring. I'm not going to show how you can get from ArchiCAD to Revit, but you can do some pretty interesting things with some of the newer tools that are out there, like computational design tools. Does anybody here use Grasshopper and Rhino and all these things? All right, it's a couple. Good, good. So what we're going to look at today is basically doing things in Grasshopper using a plugin called Geometry Gym by John Mersham. He's a guy out in South Africa, a brilliant engineer who develops this stuff on his own. It's actually a pretty good product. So what it can do is, essentially, you can build up an IFC file in Grasshopper without having to know too much about how it goes together. So we're going to take a simple example here, and this is very simple, but obviously you'll be able to see this can become more complex. Essentially, you're going to need to know, for those that don't know Grasshopper, it's kind of a parametric design tool. We take input from parameter A, stick it into a widget, out comes, it does something to it, either it moves it, it multiplies it, something like that, and then we have results on the end that we continue to connect together to get geometry. So in this case, really what we need to do is we've got to make up the geometry for the IFC file. We've got to make up a container for it, so it's levels that it sits on, the building that it's in, the project that it's in. And then we also have to give it like layers. If we're talking about walls or floors or something like that, so we kind of have to develop those layers so that when it comes into Revit, it understands what those objects are. So we'll look at the geometry real quick. I mean, this is going to look like gibberish to a lot of people, but essentially I've got two rectangles that I'm building right now. I moved one up high, one down low. I twisted the top one, and I made a loft in between. So which is this shape down here. And I've also set a series of points that would match my floor to floor in there as well. And what I'm going to do is divide that. Sorry, so now I have edges for my slabs. What we're doing is a slab example here. So that's my slab edges. And then from there, I got to give them something to sit on in Revit. So I'm going to give them some levels to sit on. That's pretty easy to develop. I have a floor-to-floor widget. I have a number of floors that I'm going to use. I concatenate that together and put it into an IFC building story container. Every IFC file needs a project. So this is showing the IFC building and IFC project. And then we get into material makeup. Right now what I'm doing here is making the two different. I want to make a concrete slab, so I'm going to have concrete and topping. So I start from left to right. I start with defining the material first, an IFC material. Then I define an IFC material layer, then a layer set, and that goes into the slab type. And you'll recognize this. That's basically your product at the end, right? So I have two layers, one topping, one concrete. All right. So all of that information that I just created, it goes into this guy right here, which is a standard case. It's basically the instance of the slab itself. So from there, and you can see the preview geometry. What's also cool about this, that geometry doesn't really exist. If I close Grasshopper, that will all go away. So it's just data right now. There's no big geometry. There's no surfaces, no solids or anything until we kind of bake it out. So then we hit the Easy Bake Oven, stick it in there. Side note, I heard that they make Easy Bake Ovens for boys now, starting this year. Believe it or not, it's a fun fact. All right, so from there, we generate the IFC file gets generated out, and then we use this tool called Geometry Gym, which is there's an add-in right inside of Revit. And what that allows you to do is actually import the IFC. And that's a little different than Revit normally handles things, right? Normally you can open the IFC file. not generally imported. So if you already have a project, you can merge this in with no problems. So ta-da, that's what we get, right? But what's cool is that we also get all the level information as well. And if we have levels in here already, like I did, I had levels 1 and 2 in there, it will use those levels and then extend up. All right, well that's pretty cool, but we can also get into adding rooms, right, and spaces. So we're doing the same thing, we just give it some geometry that actually makes up the space. So I go through a series of parameters and get all this other stuff connected, and this is what we're left with. So we have this extruded area solid. It's representing our surface, our volume of our space, right? We dump that into Revit via the geometry tool, and what it does is it kind of automatically creates the room separation lines, which is pretty neat. So you get rooms, and the extents are correct because you've set the height of that thing, so it's all in there. It's very useful. I mean, especially for early on design, you can do a lot of iterations of towers and programming and dump these into Revit for development plans and sections and things. So this is actually an interesting. I mean, everybody use adaptive components out there and all that fun stuff. Anyone? Facade design. Okay, cool. Got somebody out here. The adaptive component inside of Revit is, it's a very powerful thing, but it's rare that we get designers actually using it. A lot of times people are in Rhino and doing grasshopper like this. So this is simply a video. I have a curve in Rhino, and then what I've done is I have a definition that develops an adaptive component, which is down there on the left. In my case, it's a simple panel that I can move in and out, left and right. And then what we're going to do is we're going to instantiate that on the larger curve, right? So we're going to get that eventually into Revit so that it generates an entire curve wall, or a curve wall-like thing. So the trick here is you define the points. So basically you're defining the family, and then then you're actually locating it. So I'm dividing that curve up, into a normal grid, and then I'm moving those points in and out. So I just have to provide all the points inside of Revit for it to kind of hang that skin on. So as we go through that, it's a little tricky because you have to make sure you get the points in the correct order. It's just like any other adaptive component. It has an order of points. So in this case, 0, 1, 2, 3, 4, 5 is the placement that I need to have happen when I get into Revit. So we bake it out, save out the IFC file. Pretty standard stuff here. And then we just do the same thing. We bring it in, just import it. If I can ever find the add-ins tab. There we go. I found it. I'm pretty smart. Okay, so there you go. What's cool about that is if you notice, and this is a little hard to see there, but the panel itself, it changes its depth as it goes along, because that's just something I kind of wrote into the script. So you can get some really complex shapes onto a curtain wall or to anything. It also makes the family for you. So there it is. There's the family editor. That family is already generated for you, and you can do any additional editing you want to it. So if you want to add mullions or glazing or anything like that, you can do that. So this is another kind of interesting example as well. These are all real simple things, but they're things that are kind of difficult to do in Revit, and that's why I'm showing you using this tool. So this is creating a spiral grid system, so a true spiral. You have to dust off your trigonometry and your math here a little bit. But essentially, I have a slider that controls the number of points that I'm going to have, which therefore controls the number of grid lines I'm going to have. I do a little bit of math here, cosine, sine, blah, blah, blah. Anyway, I get a spiral series of points. And all I do now is I just grab a subset of those points, and I'm going to connect the two lines together, and that's going to represent my grid. So let's see if I can catch up to myself. So there we go, there are the points. And I have to name these things, right? You can't just send anything without a name. So you can get the entire number of points. You can use that to inform the actual grid to say, all right, your grid 1, 2, 3, 4, 5, or A, B, C, D, right? So you have U and V grids. They have to name differently. So I have that. What's also kind of cool here is using those same points, I just kind of lofted them up and then drew a line in between and then extruded a column shape on it. And then turn that into an IFC column. Right? So all you have to do is, if you can build the geometry and give it a container, the plugin does the rest. It actually writes out the IFC file correctly. Let's see if this lets me do it. I can also move that line parametrically on those grids. So when it's all said and done, let's see these pretty columns. There they are. Okay. So again, this what's nice about this too is when you bake this out, those columns become Revit columns, and they will sit on the grids and be associated to those grids. Let's see if this keeps going. Sorry, I'm going faster than my my screen here. Yep, got it. Bake it. There we go. So what's interesting too about this is that this was I originally developed this little script when we had Revit 2012. Now Revit 2013 allows for multi-point segment grids, which weren't just weren't available. And I think they've opened that up in the API. But currently, when I bring this in, you're going to see. Whoa. You guys still see? Because I lost all my signal. There we go. Sorry, guys. So there you go. So grids 1 through 14 all came in, and connecting grids went around there. Now that would be pretty hard to do inside of Revit to actually get those orientations correct and get those intersections exactly where you want them to do. I don't know if anybody's going to use anything with this or design a spiral building or anything like that, but it is a useful use of the technology. Okay. So the takeaway from this is really that you've got complex design data in these Rhino files or in Grasshopper, and really why recreate it? Because generally what happens is they'll dump out an SAT file, you try and make a Revit mass out of it, you'll try and get some floor slabs out of it. Doesn't always work, right? Especially depending on how well that initial mass was modeled. So the key here is use IFC, use this tool, don't redo your work. We'll get into the program validation side. Has anybody here, you ever heard of a program called Deropus? We use it? Yeah. The developer Deropus sitting in the back row there, so obviously he knows. Deropus is essentially a program validation tool. It's an online, it's a not web-based, but it's internet accessible. So it's a way to manage program requirements, FF&E in a building, and technical requirements that go into a project. So essentially, you enter those things in, and then there has a very robust connection between Revit and Deropus. So Revit may give you a designed area. It can help you place the equipment in those rooms. It checks to make sure that it has that equipment in those rooms. So it's pretty robust connection with Revit. That's why we use it. It's really good. So you might say, all right, well, why does IFC really matter here? All right. Well, again, when you're in Deropus, we have to do a lot of validation, and all the reporting, so data sheets, any kind of area reports that we want to do can be easily generated in Deropus. But what's really interesting that they've just kind of developed is they have a new connection to the IFC model server. An IFC model server, we're going to go into this a little bit later, but essentially it's a repository, it's a database of the IFC schema, and it can be multiple models all together, and you can check the parts out, you can do lots of different things with it. But it lives online, it's accessible by all the other applications that are designed to hook into it. Unfortunately, Revit has no IFC model server plugin right now, but hopefully that's something we'll look at in the future. So the process is right now, we dump it out of Revit to the IFC model server. So we just make a normal IFC file, and if we have a project like a hospital where we typically do, we have 7 or 8 files that make that up, we dump them all out to the IFC server. And Deropus can coordinate through that. Well, I'm going to show you real quick here. I pray these videos work. Yes, we're going to go. So what we're going to show here is the actual connection to it. To start the connection to the IFC model server, all you have to do is hit the show bin button, which is kind of cool. This is just a demo database that we have. And believe it or not, this thing, as we're doing it, I know this is a video now, but we're connecting out to a server in Denmark. And you can see how fast it loads up. So what this allows you to do is visualize the program and the entire building from that IFC server. So if this was multiple files, we can still look at all the different areas. We can look at the programs, the functions, as we go. What's new, this is just new in this one, we can actually dump this out to Excel really quickly right from here, which is kind of nice. So you can get area reports very quickly, put them in Excel, and use them for other purposes. So move on from there. But what's really exciting is you can browse the program and visualize it at the same time. So rather than just look at this list and try and figure out where you are in the building, you can see it in real time. And then you can get into a detail level. Right? So just by double clicking on the room, it takes me into all the geometry that makes up that room, everything that's in that room, and all the information about it, which is really cool. That's something that you can do quickly anyway. And even in Revit, it would take forever to pan over to these things and get around. So you can see how quick this thing is. It's pretty impressive technology. What's also pretty interesting is we can do validation right here. If we open up maybe the equipment in the room, so we can see what's in there. So it gives us a list of everything that's in there, stuff that's been modeled, stuff that still needs to be modeled, and we get warnings. In this case, I need 2 of these particular cabinets. I only have 0, and then the other one I only need 1. I have 2. So it can do that type of thing, and we can actually go back and see what that piece is and try and see where it can fit in. So in addition to just viewing the program, we can also view pretty much the entire model. If we go over to this side here, we can actually look at the floor plans. And what's also kind of cool about this is, like, depending on your scale, you'll either see spaces or you'll see the actual detailed data, which is kind of neat. So as you back out, it kind of fades out to the just to the space information. And the spaces don't kind of hide what's going on inside there. You can select on them, but as soon as you select away, you can still see inside. So in this case, we're just looking at the first floor, or we can easily look at the next floor. We can also do some interesting reporting stuff in here. So if we look over here, we can go and look at, I'd say, rooms that only exist in the program, so they haven't been modeled yet. So we get a nice list of that. We can see, all right, well, we still don't have that patient room, we don't have that bathroom. We need to put those things in. Or more importantly, I think for our end, is rooms that are in the model that aren't in the program. That happens a lot. Sometimes people forget to place the rooms from this program, and they'll just put rooms in, and we won't have a connection between the two. In this case, what we're getting here is we're actually getting the areas. So the gross areas aren't in the program, but because of the way Revit was set up, it'll dump out a Revit area as an IFC space, right? So it makes no difference between rooms, spaces, or zones, unfortunately. So you either have to set that to be off, or you can leave it on and just ignore it. So this is I just got a couple slides. This is a really, really large scale version of that. There's 12 Revit models in all, and I can't imagine how many rooms, probably over 1,000. And this thing handles it very well, so it scales it up pretty quickly. All right, there's another interesting module of the Ropus that's in the works. So this isn't something that's commercially available in the United States yet, but it's on its way. It's a program, it's a module called TITA. And what that means is it's a technical information database. This is really about building and operations management. So what it does is essentially it's a systems view of the project. So we just looked at the programmatic view of the project. Now we're looking at a systems view, so we can look at anything. And what's really cool about this is that it has object recognition and auto code assignment. All right, so what that means is, say you have a Revit model, either an MEP model or even a detailed fabrication model, right? What it attempts to do is read that information as it comes in, and whatever omni-class code or whatever coding system you're using, if it's not coded properly, it'll try to code it based on what it knows about the whole system. Right? So if you bring in, it knows that a duct is a duct, a pipe is a pipe. It'll know if it's part of the exhaust system or it's part of the supply system. It attempts to try to code that and it warns you. It says, all right, well, anything in green, we can easily code. Yeah, that's okay. Anything in yellow, we're kind of sure we made it. And anything in red, they just don't understand. So you can manually code that as well. So that's pretty powerful technology. And then on top of that, it's extremely flexible. You don't have to have everything modeled in order to track information about it. Like waterproof membranes, we never model those. But we have warranty information about them. We have cut sheets about them. We have a lot of other data that we need to track. So you can do that as well just by adding something in there. So what's cool about this is not only do we get into actually, let me back up. I'll show you all the other. So the approach right now is the IFC model. The IFC model server is coming right now. It's just a dump out to IFC and then into Ropus, and that's where we can add in commissioning info. We do cut sheets, maintenance, warranty, as well. All of it's pretty customizable. You can add different forms. It also keeps a log of what was added when and by whom, and anything that's been deleted by whom, which is pretty useful. So the key here is that at the end of this whole thing, you have a COBE deliverable or an IFC file that you can dump into any FM software if you're not going to use this particular software. So a lot of the projects we're starting now that are 5 years down the road, the owner has no idea what FM software they're going to use yet. So either they have something in place or not happy about it, but we as architects are required to deliver an FM-ready model, at least some of the projects I'm working on. So the way we kind of cover it is we're just adding detail now, we're adding all the information as we can, and the COBE deliverable at the end of the day will help us get into the other software or whatever they decide to choose. So again, this is not available yet, but it's coming. It's big in Scandinavia. And right now, like this is an example of a Scandinavian coding system. So, but this could be OmniClass, master format, or a custom coding system altogether. We're actually trying to work that out right now, what that might be. Okay, so that's program validation and FM handover. And the big thing here is that it's the point about the IFC file right here is that it's really flexible. It's a flexible tool for FM handover. This is, you don't want to lock it. You can't hand a Revit model at the end of a project and expect the owner to be able to use that or do something with that. You got to give them something they can use in their operations and management if that's what they're asking for. So an IFC kind of answers that. This one's kind of fun. Performance-based design. So what that really means is basically simulation and analysis. And one of my favorite things to do is I'm pretty big into pedestrian simulation. There's a tool called Mass Motions. Anybody heard of it? From Arrow? Anybody try it? Use it? Okay. It's a great tool. There's a couple tools you can do out there for pedestrian simulation, Simulax, Legion. But Mass Motion is really the only one that lets you build in 3D, design in 3D, and simulate in 3D. So when I'm saying what you're building a simulation model, right? We have these Revit models. They need to be kind of pared down so that a simulation engine can understand it. So there's usually a lot of rework. I got to remodel this whole thing and make sure it's exact and try and keep up with the design. So what ends up happening is we do these pedestrian simulation analysis at the end of DD, at the end of CD, when really any results you get from it are not going to have a lot of impact, right? So the idea here is to push that forward and use it early in the design process. So I'll show you an example of that. This is a fairly simple Revit model. It's a model of a international arrivals terminal at a very, very busy airport out in California. I can't see which one. But anyway, what we've built here is a check-in area. So all we're looking at is to ensure that we're looking at 1 day or 1 hour of 1 day on Sunday night to make sure that there's enough desks available to check in all the flights that are on the flight schedule. So to do that, we have to build the simulation model. We have to let people know how they're going to get into this thing. So there's certain parts that we have to put in. These little families here we developed kind of custom, but it's they're just generic components right now. Generic model adaptive components. So it's the only way to really get a plane in Revit. If you ever wanted to get a single surface in Revit, the simulation engine we're using needs that. So that's actually quite difficult to do. So you finally kind of hack it together. But when you're doing a simulation, you got to give them a portal. So that's a way in or a way out. It's where people kind of are born or die. They need links. They need to be able to get across floors, understand how to get through doors, and get through turnstiles. There's escalators. IFC, just so you know, it does support the transport element. It does support escalators, elevators, everything, but Revit obviously does not, right? There's no good category for vertical transportation at all. But something's been sorely lacking for a long time, and we're still to address it. And of course, stairs. So when this first, and lastly, I'll talk about one more thing, is they need floors, right? They need something to walk on. So in this case, we're going to use spaces instead of actual slabs, but you can do either. So when we first started this project, the way in from Revit was FBX, which was kind of plagued with all kinds of problems and a lot of manual assignments of things. So we told them, well, why not look at IFC and try this out? And within a week, they were able to develop a pretty good working prototype. So what it can do is it can read in the space, and it'll find that bottom surface of the space and turn that into a simulation floor to allow people to walk on it. It takes any IFC door, it turns that into a link. These are all manual things I had to do. I had to draw these things in manually. But now all this stuff is, the intelligence is already built into the model, so why not leverage it? Same thing for elevators. For stairs, you can convert stairs. Walls become barriers, railings, columns, all those things can come in that the people have to interact with. And so what you're left with, get back here, make sure that plays. So what this tool does is actually allows us to analyze things much earlier in the process. So right now what you're looking at, you see these little people moving, if I zoom in, is a 1 hour on a Sunday night with the given flight schedule for this airport. And it's for 2025, so we've kind of added a few extra things in there. Like I put a worst case scenario of 4 A380s departing within 15 minutes of each other. You know, those planes hold 400 people, right? So we can apply curves on when people get here, but you know, it's not the most exciting thing to watch. But it does look realistic, right? I mean, this is basically what's going on in an airport, so we can understand that. All right, they need to have more check-in counters, and you have less check-in counters. There's not enough queuing space. We'll see that in a minute. There's a couple flights that are woefully understaffed. Right here, we can get live heat maps, so we get live data as these people are moving through densities, so we can kind of see where things are bottlenecks. And you can imagine if this was an egress simulation, we do the same thing. It's very good with egress and emergency evacuations. So we run this a lot. So again, this is obviously there's much crowding for this flight. Too many people, not enough check-in desks. So what's nice about that is you can also render it out to mental ray. You can actually get a really nice rendered animation out of that. So the point there is by doing pedestrian simulation early in the process, we can start to inform the design. And we're using this on more and more projects, not just big airports or anything else. We use it for tower evacuation. So anything over 50, 60 stories, we want to look at our stairs wide enough, we have enough capacity. We can look at things like elevator-assisted evacuation. All of these things in concept design, you know, very early in the process, and that's something we never really did before. And we're not engineers. We're not staking our name on this. We're not saying this is the way it's going to be. It's really just to inform our design. They'll still get pedestrian studies done by, you know, Park and Sprinkler Hall or somebody like that. So this is another neat product, Synergy. I'm not really much on the energy modeling, but what it is technically it's a graphical user interface for Energy Plus. It's currently being developed by Lawrence Berkeley National Laboratories. It's in beta, but anybody who's used Energy Plus knows that you have to have some kind of interface on it, right? It's just text. Or command line entries, and it's notoriously difficult to use. But what's interesting here is now you can take something from the building information modeling. Previously, the only other tools out there really took GBXML, and I don't know if you guys use GBXML. It's another type of schema. It's got some issues. There's not as much information attached to that can be carried, and Revit does sometimes a good job, sometimes a bad job getting that information out. So this is the only tool that can actually take IFC, which is kind of exciting. And we see here they're using another type of model view definition, and that's the conceptual design bin model view definition. And essentially that was built for energy modeling, or for what it basically describes as a conceptual version of the model, so it kind of extracts out and makes the building into more of a conception, right? You don't need all the detail, they don't need chairs, they don't need doors, all these things. It kind of dumbs it down, I guess to say. But it consists of, so after it brings in the IFC file, it's got a geometry simplification tool that goes on top of it to kind of simplify things out. It's also got a space boundary tool. The space boundaries are what comes out in the IFC. We have two levels of space boundaries, one being the exterior space boundary, and two being all the interior space boundaries. Now that's a tip, and I'll show you this later. You can turn that off if you're not doing energy simulation. There's no need to have that turned on during the export, and if you do, it actually takes a long time for it to churn through. So if you're getting a slow IFC export, turn off space boundaries. So anyway, the other downside to this though is you have to manually specify zones. IFC has no concept of zones right now. So HVAC zones or exhaust zones, that's coming. I think it's part of IFC4. But currently, like I said before, there's a lot of ways to draw kind of room objects in Revit now. We have spaces. Now we link them together. We have zones, we have areas, and we have rooms. But to IFC, it's just a space. The whole thing is a space. So that's a little bit of a downfall here. And another interesting thing, I know a lot of these programs do this, but I think it's pretty cool that you can design the HVAC system graphically to put that in there. Okay. So again, the takeaway from this is simply IFC allows analysis to inform design much earlier in the process, and that's the whole goal here. It's not we're not MEP engineers, we're not structural engineers, we're not pedestrian simulation engineers, we're architects. But what we want to do is be as intelligent as we can about our design. So by doing these things early in the process, we can inform it a lot more efficiently. So model-based coordination. Everybody does model-based coordination nowadays, right? Clash detection, a lot of people use NYCRUG, right? Here, Well, there's a couple things you can do with IFC, and obviously clash detection is one of them. And some of the tools allow for automated code compliance, which is a little bit new, but it's very powerful stuff. There's two main products that I think are pretty interesting here. Tekla has BIM-Site. Everybody ever used Tekla BIM-Site? Yeah, it's kind of a neat tool. It has rudimentary clash detection. It has a markup system. It has the ability to take in very large IFC files and handles them very well. And honestly, you really can't beat the price. It's free. So I would go out and get it. If I were you, it's actually a pretty interesting thing to do. It doesn't have the same capabilities of the next product I'm going to show you, but it can do a lot of things that Navisworks can do. But obviously Navisworks is a little bit better than this. But my favorite product is Solibri. Does anybody use Solibri Model Checker? All right, some people in the United States is good because this is a biggie in Scandinavia. People like this one. And what I'm going to just show you now is just kind of the differences really between Solibri and Navisworks. And what it really does is it goes beyond simple clash tests. Like you start to look into to design issues, right? Do the architectural columns completely contain the structural columns, right? There's no good way to do that. I can tell you in Navisworks whether or not the structural column is clashing with the architectural column, but I can't tell you if it's inside of it or if it's 4 feet away from it, right? So these are the types of tests you can do, which are important. Same thing here. Does the beam actually fit within the wall casing? Well, in this case, no, it doesn't. And even better is it gives you really nice human-readable descriptions of the problem, which I think is pretty cool. One of the hardest problems I always had in Navisworks, and they are addressing this, is finding out where that clash actually is in the building, right? You can get a whole list of clashes, but understanding where that is, especially on a large, complex project, we used to have to do a lot of hacks with getting grids in and levels and stuff like that. I understand 2013's had a long way from that, but this always has done it automatically. And what it does is it gives you the space. So it tells you it's in the ceiling of room 204. Go look there. It also does BIM validation, which is kind of neat. And that's, we're starting to get into, obviously everybody's using Revit models and building information modeling, but is everybody checking those models carefully, right? This really just asks the question, does it make sense? And here's an interesting test. Are the walls sensible dimensions? Are there any tiny walls? Are there any too tall walls? Are there any walls that can't possibly be constructed? And in this case, somebody modeled this as a curb. They wanted a curb instead of drawing a floor area, I'm sorry, a floor slab profile. They just modeled as a wall. So, not great. Or is the space below, a sensible square footage? In this case, it knows it's not a habitable space, but it knows it's a storage. It's for storage. And our test says, all right, well, if it's below 10 feet, is it even useful? In this case, it's a very, very teeny janitor's closet. I don't think that's why I kind of failed the test. It wasn't useful. And it does deficiency detection too, so it looks for problems. Like in this case, there's no column. There's a column in there. Nothing. It doesn't touch anything above and below, right? So it's not sitting on the slab. It's not carrying a beam. All right, that could be an issue. Maybe it's not an issue, but it could be. You should look into it. Here's another one. Being supported by what? Air, right? There's nothing underneath it. There's nothing above it hanging off. So these types of tests are kind of, you might laugh, but it is interesting to see that. And it goes through it and finds all the different problems that you may have and stuff that you may have never seen before. Whether your slab, your structural opening slabs match the architectural openings of the slabs. Is the shafts lining up? Is there anything intruding into those shafts? It understands openings. These are the types of tests that are difficult to do in Navisworks that are fairly easy to do here. And this is why it's becoming, at least in HOK, more and more used every day. I mean, obviously Navisworks is ubiquitous, but this is a better tool, in my opinion. It can also do code compliance. So it has a fairly sophisticated set of rule checks for ADA. This is a simple example. It's looking at, from the IFC file, it's looking at turning radius. And this is actually an image of our office here in NYCRUG, New York. And that's my boss, Carl Galeoto's office. And obviously you can push in this chair, so there's not quite enough room. What's interesting about this is it gives you the maximum. So the red is what you need. And there's it's hard enough to see here, but there's a green line that tells you what the maximum you can get in that space, and it also reports that out. Same thing here. This is the entry to the men's room. This is 2 doors in the series. It's saying that the door swing of this one, it's actually a little bit too close to the other door. You need to be at least 4 feet apart based on ADA rules. So Again, this is stuff that a technical architect will go through and look at plans and measure out. But it's also nice, it's not a replacement for that, but it's nice to be able to see these things ahead of time and address them before they become real problems. Life safety is another big one. It has a pretty robust set of life safety checks. Essentially what it's there, you have to kind of, the IFC model itself, when it comes out, you need to define its fire compartments. So it needs to understand, it understands where the rated walls are. You can build them based on those rated walls, or you can build them by grabbing a bunch of space and saying, this is a compartment, this is a compartment. So what it does then is it looks for all exits, it knows where its exit stairs are. It looks for the maximum distance between all those exits. And in this case, our model room, our model shop room, this is all before it was actually built, but our model shop was actually a little bit too far from the closest stair. So I think the max path is 50. This was probably about 51 in some. So again, useful things. Yes, you can do this manually. You can use the good old Steve Stafford widget guy, right? You draw around and measure out and schedule and get the total length of egress. But to be able to do it with an IFC file inside a model checker, be able to report it cleanly, it's quite useful. And while we're on the topic of coordination, we can look at design collaboration, right? And it's an exciting format that I kind of recently discovered, maybe about a year ago, is BCF. Anybody hear about this? .bcf? It stands for BIM Collaboration Format. And it was developed jointly by Tekla and Celebri and a few other companies. But it's not technically a Building Smart initiative. It's called a partner project or something like that, but it's very closely aligned with IFC, and it's based on IFC. So the idea here is that you transfer issues, not models. Right? We both have models. You have your model, I have my model. We know there's problems in there. Why am I bundling up NWCs into an NWD and transferring a 200 megabyte file to the other person just so they can see the clashes, right? And then also usually you're going to have other notes or anything else in maybe a Word doc or whatever else. There's no good way to kind of track this information. So the notion here is just send me what's wrong and I'll find it in my model. And that's kind of the opposite approach of Navisworks. And there's a tool by, this is actually so new that it's really, there's only one tool out there that does this. There's only one plugin out there that does this, and it's really developed for the Scandinavian market. And you'll see that's a common theme. The more stuff I talk about IFC, the more stuff you're going to hear about Scandinavia, because they're way ahead of us on this. So we'll just do a quick demo of this. What I have is a real small IFC model. Well, it started life as a Revit model. James will probably recognize this. He always builds these. This is our Navisworks training model. So anyway, it's just an HVAC model. It's got some structure. It's got some architecture. And I'm running some checks here, and I'm looking at, let's look at structural versus architectural, and make sure doors don't hit anything else. And obviously I found some problems. There's a column there. There's a double door there. They're intersecting. So what you do is you make a report in Celebri, and this is how it works. You just kind of make some slides. You can add notes to those slides. So in this case, you can see I asked to make it a single. Show you how to edit those. So we edit the issue. I can add any kind of text in here I want. You see automatically the location's filled out for me. It knows it's on level 2. It knows it's in the administration room. And it's the second door into that administration room. So I hit OK. And then instead of dumping this out as a PDF, like a unit might or a Excel file, we can dump it out as a BCF report. And it's a BCF zip. So we'll do that. And then we'll hop over to Revit on the other end. And there's a tool, again, this is a tool by a company called Naviate. It's not really in the English market, in the United States market yet, but we're actually testing it right now. And what it does is it allows you to open up that file, and you get a nice little list of issues. There's my 2 topics on either side. It tells me what IFC files they came from. It gives me a list of the comments. I can enlarge that just to see what's going on there. And then what's really cool about this is the big one. Now I can show those components, right? I can select them right inside of Revit. So I know it's these 2 components that I'm dealing with. They also have a nifty tool, an automated 3D selection box based on selection. So that's what you're seeing there. It's kind of cool. So in this case, he asked me if I can make this a single. I don't think it's a problem. I'll go ahead and do that. If I can ever get fast enough. There we go. Did that. All right, so that one's done, but I'm going to go back and tell him that, okay, I mean, you don't really need to do this, but I'm going to say, okay, yeah, I did it. So I'm going to set the status. Here's some information for you. The verbal status is essentially what matches up in Solidity with their issue status, whether it's closed, open, assigned, or unknown. So I'm saying it's closed. I'll say, okay, no problem. Save that. You'll see that this says the second comment there. And what's also pretty neat is that it automatically took my username right from the Revit username. So whoever's logged into that machine, it's going to automatically track that. And I'm not allowed to edit anybody else's comments. Right? It has to be me to do this, and it keeps a complete list of all the comments that happen. And there's no way to delete them either, which isn't good. Right? So you don't have to say, oh, I didn't tell you so. So this one I'm going to say, no, it's a warning. I can't move this right now. Can you move the column instead? So I said, okay, and then we save it out. You can save it right over top of the other zip file, but I like to save it as a dated file, just saying, all right, here's my response. So let's see if I did that. So I did, responding. And in addition to that, which is, we could just send them that, but I'd also like to send them the IFC file that's been updated. So we just dump that out. After I show everything here. Okay, so I'm just going to overwrite, just like you would do in Navisworks, I'm just going to overwrite that IFC file, just like you would overwrite NWC. So here we are back in Solidity. I'm going to update that thing. I can set it to automatic, but in this case I did a manual update. And let's see here. If we go over to the Communications tab, you'll see that the slide didn't update because I didn't regenerate the thumbnail. I could do that right now, but you can see obviously the issue has changed. So now what I'm going to do is update that presentation from the VCF file that I just got back, and you'll see there's additional comments now. Yeah, there's my comment at the date and timestamp. It says, okay, no problem. Here's my other comment that says, nope, sorry. Door stockroom must be double. Can shift the column. So at the same time, we also can recheck the whole system. So I'm running the same checks again. And obviously, I get one less result, right, because I'm not colliding anymore with that. So I can update that presentation again. But this time, instead of from the VCF, I'll update it from the results. And it'll automatically remove that as a problem. So you can either duplicate these presentations, or you can kind of keep one general coordination presentation going the whole time. So anyway, it's only supported, like I said, right now by let's see here, by Solidity, Tekla, and a plugin for Navigate. But I'm hoping that it gets picked up by a few more things because I think it's a good idea. I mean, there's no sense doing this, and in Navisworks, you can add comments, but it's a little bit more cluttered, right? It's hard to see the exact string of comments that happen. It's kind of, it doesn't keep track of when you change what status, or maybe it does, but it's difficult to find. So I think this is a better way to do it. Again, for collaboration, I'll talk a little bit, we're almost done here, but I'll talk a little bit about our model servers. Again, these are pretty cool things. The one that the Rofus uses is by EDM, Express Data Management. It allows you to do lots of things. There's an open source one too called bin server, which is kind of neat, that you can just download that right now, fire it up, and run it on your desktop, or run it on the server, or run it on a laptop, whatever you want to do. But it allows you to check out portions of the model. You can subscribe to changes in the model. So anytime something changes or updates, you get a warning. There's a lot of versioning control in these built into these things, so you can always kind of step back and understand who did what when. And then, which is kind of neat, you can generate a subset of the IFC file right on the fly. So say you're an interior designer and you're working on the 6th floor of this massive project. You don't need the whole IFC file. You just need everything on the 6th floor or everything in your zone. Boop, hit it, done. It generates it for you. And it's about data management, not just geometry. So all the attributes that go on top of that are all available there. It's I guess you can compare it to kind of PLM for buildings, right? So it's kind of parts management, if you want to use a mechanical engineering term, or inventor, or anything else. So obviously, it enables collaboration. So we'll talk a little bit about the nuts and bolts stuff, the exporters for IFC. So now that we're getting into Revit. Believe it or not, right now, the Autodesk open source exporter is your best bet. I wouldn't say that about a month ago, but today it is. They've done a lot of work on it. It's constantly updated. There's a good group inside Autodesk working on that right now. And I think everybody's kind of got their attention that it was substandard before. So you can do some interesting things with it. I'm going to show you quickly how to prepare for it. Everybody ever do this before? It's the same thing as kind of the layering standards. if you're exporting the data, if you're changing the DWG standards. You can assign Revit object categories to IFC schema. You just need to make sure, like, unfortunately, you can do anything on this. It's good and bad. But you have to make sure that it's part of the IFC schema. You can't just say, oh, this is IFC ductable or something like that, because there is no such thing as an IFC ductable in the schema. So it'll build it, but it won't be recognized as anything. So you just want to make sure that when you're using this thing, you want to understand what's what. And it can be confusing, like, what would you think an electrical socket is? Would that be IFC electrical socket? Unfortunately, no, it's actually IFC flow terminal. Because electrons flow through it, it's a terminal for a flow. So there's a type within that, so then it becomes a receptacle beyond that. So you have to look at the broad base first and then get into the lower ones. Now that's hard to do. You can't do that. Oh, all right, let's just go over this real quick. So to get the exporter, you can follow this link right here. This whole presentation is available online, so you guys can follow along and rewatch the videos or do whatever, click on the links. So to export it out, you'll see it's a different interface than the one you're used to. You have some options here. You want to use the 2D plan view elements if you want to get the grids out. If you notice back in Solidary, the grids were coming through, the levels were coming through, the floor plan kind of view of it was there. That's all coming out from the IFC file. Now you have to just set IFC grids to come out, because right now by default, Revit says, under grids it says do not export. All you do is change it to IFC grid, and you're done. Now, if you got something custom, like say mechanical equipment, right? Mechanical equipment is a very broad category in Revit. There's lots of different types of mechanical. There's pumps, there's VFV boxes, there's all kinds of things that are there. And if you just change mechanical equipment to, say, flow device or something like that, there's not enough granularity there. Some tools can pick that up and you can classify those objects later, like in Solidary. But you can do it in Revit, believe it or not. There's two shared parameters you can use. IFC export as and IFC export type. If you add those shared parameters to your families, now this is non-system families, this is only families that you can build, you can set that to export. On export, it'll look to that and say whatever, it'll ignore whatever in the normal definitions and use that on export. So it's kind of a power, it's a nice thing to have. It's cumbersome though. If you want to build all your families like this, it's probably too much. I will use it on a special case where you absolutely need to do it. There was just an article in Augie World, I don't know if you guys read that, but a guy who was able to get something in the Revit roads category via this route. He dumped out a generic model that was like a slab, called it IFC road, brought it back in to Revit, and it actually showed up in the roads category. I don't know if you've ever noticed that category. It's there. You can't use it, can't touch it, can't turn it off. You can turn it off, but it doesn't do anything. So I don't know. Is that useful? I don't know. I don't know why you need roads in Revit, but you don't need elevators and escalators. Now, there are a couple tools out there that are strictly IFC editors, so they can take what you dumped out of Revit or any other tool and edit it further and make a new IFC file. They're really good for geometry trimming. So if you want to say, if you dump the entire IFC file out, you only need a subset of stuff, and you don't really feel like setting all the other settings, you can go in here and just grab what you need and make a new IFC file. You can also enter some of the parameters as well. This tool I'm going to show you right now is called Simpleton. This one does not allow you to change the class of an object, but you can easily trim things. So this is a pretty simple model. What I want to do is it's an interior office fit out, and I want to grab just the furniture. So I'm going through, I can select different objects, and see there's two boxes here. It's hard to read. The lower box is exclude, the upper box is include. So I'm going to take all the ceilings, all of this stuff until I can see the furniture. I'll get rid of the lighting too. So we zoom in here. I can grab, say, all the furniture. I can grab things by instance, or I can grab it by the entire class, which is kind of nice. All right, so there's all the furniture there. That's what I want in my model. I'm going to select everything else in a second here. There we go. And then I'm going to throw that in the exclude file. All right, so now what I'm left with is everything's been decided upon. I can just dump out another IFC file right from this program. And this is a good way to kind of optimize IFC files. Sometimes they're a little bloaty. There's a lot of extra data there that's not necessary. So you can just go through this process and make a much smaller file usually. So I'm making that. I'm going to bring that file back in just to demonstrate. So that's the same file. There it is now. It's just that. But what's nice, this tool can also access all the parameter information. So we just kind of drag and drop it over there. Keep going here. Sorry. Oh, this is my favorite part. This tool also has, I can't see it here right now, an explode button. So you can, if you're getting, it's a totally useless thing, but it's called Big Bang. You just stick it in there, and if you're getting feeling frustrated, it allows you to explode it from any point. It's kind of a fun therapeutic little tool. So back to here. Anyway, the point is, you can edit some parameters. Like what I could do here is maybe change the type mark of this object, or change its Omni class, or change any of the tags that came out of Revit. Most of them you can change, not all of them. You can't change the actual geometry shape or what it was made from, but you can change a lot of the data about it. So we already looked at that. And there's a few others out there. There's GDS CAD, which is an IFC viewer. That's free if you can find that. There's a Soybean model viewer. That's another freebie. You can go ahead and download that. There's an IFC optimizer for Soybean, which basically strips off all the extra information that maybe that the exporter dumped out that really isn't necessary. You can open it up in Excel. You can open it up in Notepad if you really want to, and take a look and dive in to see how these things actually put together. And then, of course, bin site. So, all right, well, what's the whole point of this? Well, Revit, obviously, we have a mountain of information. We put a lot of effort into it, and we do a lot of things. But there's so much data in there that you can really use downstream with applications that are never going to talk to Revit. Maybe some will at some point, but the majority of them are not. They're not going to speak Revit's language, nor should they, really. I mean, there's just so much more that if the systems were open about it, we'd be able to access this just about anywhere. So that's about it. Obviously, I went through that very quickly, and I apologize for all the technical difficulties. But if you have any questions or anything like that, I can take them now, and you can obviously find me here, or tweet me, or whatever. I'm around. James?
A couple of things. The Graphisoft IFC plugins for Revit. You want to mention those? Or
yeah, they're still around. And the reason I didn't mention them now is things have been corrected so much with the Autodesk ones. But Archicad wanted to work with Revit so badly that they made their own Revit exporter for IFC that you can download. It does a lot of things like correct shared coordinates, things that used to be issues with Revit. I wouldn't download it right now until they update it because it does some funky things to the file format now. But generally, keep an eye on it. They also have one for just mechanical, where they add a lot more mechanical information than is currently available in Revit. So that's useful.
Also, I think the important thing about the IFC, and particularly things like the model server, are that it starts to become this platform that, if anybody book flights on like Expedia or Kayak.com, right? That's all possible through web services and open standards, right? So, like airlines, you don't download a whole copy of every airline's flight schedule. The minute you do that, it's out of date, right? It's all based on server. So if you imagine this, it's not that far in the future where if we were working on design, publishing our designs out to a model server, the authorities having jurisdiction can connect to our server and just basically ping our server and run a code check, or maybe a pre-validation code check on a design that we're going to say, about to submit formally in the next month. Our estimators can set their applications that are also based on this open standard, ping our server and say, oh, all right, now we have all the data for our estimate. Subcontractors can say, all right, let's pull down the structure and major architectural systems, and then we can start plugging away our stuff and contribute that to the server. Obviously, depending on permissions and all kinds of security and stuff like that, but this is a platform that makes that all possible. I think that's like the theme that is really, really exciting about this in the near future. And we've talked about this for a long, long time, and it's becoming a reality now. And we saw a lot of that last week at the National Film Conference. Chris has been doing amazing stuff that, making it work, doing real stuff. Just a couple of little extra pieces of technology, and all of a sudden, it's flowing between everybody. Sharing the model becomes a deliverable. The model is a code checking device. The model is a collaborative tool between all the building stakeholders. So, super exciting, and I think I thank Chris a lot for sharing that with us.
Sure. I guess I'll share a link with Robert and I'll put it on the Facebook page or on the meetup page. It's just on my Prezi site. You can just go through it. There's no, obviously won't be any audio, but you can get some of the information. Sure. Robert. The BIM server at where? Skidmore? As in SOM? If you're talking about it just using a BIM server for a project, like who maintains that? Well, I mean, I guess could be the contractor, could be the architect. Usually, I would say we would want control of that, but everybody has to have access to it. So there's multiple levels of permissions and stuff that can happen. Office starts to address that too. They have a very robust permissions set up. I'm not sure what BIM server has, how that's set up. I know EDM has a pretty sophisticated setup for permissioning type thing. But the whole point is to be open, and it's really not that hard to manage. You just set it up and let it run, and it's just a matter about publishing to it. It's pretty simple technology. The infrastructure's always been there, and the file format's always been there. It's more about getting authoring apps to kind of catch up and write out to these things, and be able to import them usefully too. That's probably the harder trick, is bringing stuff back in. And at least Revit has some trouble with that. Bentley does a better job. I think Graphisoft does a better job. But that's the trick. Because if you're gonna use a model server, you need to be able to get that stuff back, right, to you. So I don't know if that answers your question, but I try. Sure.
As sheet metal contractors, one of the things that we're beginning to see in contract verbiage is that the architect's going to provide a Revit model, and we have to essentially coordinate the job in Revit. Most sheet metal contractors don't use software that communicates.
Yeah.
And they Autodesk is really just now. In fact, I just got both of them last week. Packaging a product that will interface with Revit. So, this IFC tool, is there any change? Is there any software tools on the horizon that will actually allow us to take, the software, the design software that we use in our industry, and be able to
Coordinate that.
Chris, can you paraphrase the question for the online?
Well, the question real quickly is that the sheet metal contractors and really fabrication contractors are they're being asked to use Revit models to kind of coordinate the whole thing, and that's not really their domain. It's not what they use. It's not their authoring apps. And I think it's a mistake to demand that you guys use a Revit model. IFC can do this. Like, IFC is very compatible with QuickPen. That's a big one that uses IFC. I know East Coast CAD can generate stuff from Revit. Not well. Okay, all right, fine. Not well. I'm not a sheet metal guy. So I don't know. There are tools out there that are beginning to address that, like AutoCAD FabMep and a couple of the other ones. But to me, really, what you're doing is what we need from you in the end. I mean, I don't know if this helps you, but obviously, if you can suck in the Revit model and it helps to kind of start your design, the key here is that you're going to move things around. You're going to put things in the right spot. To be able to get that information back to us, we need you to do to get that coordinated and back around. So we just all I ask of our sheet metal guys is an IFC file at the end of the day. One for coordination, for model-based coordination, and more importantly for FM, because the owner wants an as-built, really, at the end of the day of what's there. And is there any sense in keeping up the design model, other than for drawings and maybe some primitive drawings, the design intent model on the MEP side? Maybe not. There's not a lot of value there. And then there's double effort. You're moving things, and then the engineers, they don't want to scramble around and move their duct over or move their thing around. So if we can grab that IFC file and give that to the owner, that becomes their as-built. That can work. That works with structure, obviously. Tech is pretty good at that. There's a couple other things, but architecturally, there's never going to be an architectural fabrication model. Maybe if you get into enclosures and things like that, yes. But that's we actually just went through this issue on a major project that we're working on, where the owner wants an FM handler and they want IFC files. I mean, they want we're bringing sheet metal guys in as trade managers very much early in the process, and they're sitting side by side with the MEP engineers now, which is very common. So there has to be a point in which you stop Revit and start whatever your fabrication tool is. because you're only going to design what you can build or what you can cut, and your knowledge kind of goes into that. So we've kind of have a little trouble struggling to find that line, but once it's there, the other one, with oversight with the MEP engineers, the fabrication model becomes the model that we're going to use. I mean, for the as-built, obviously the as-built, and then any kind of major changes that require reissuing to the city or anything like that, then the MEP engineer has to go back and update that Revit model. So unfortunately, you can't pull that back. I mean, I guess in theory you could, but I don't think Revit handles IFC import. I don't know. Mike Ortega from Cisco sitting right here, he knows a lot about that importing on to Revit MEP. So
do you believe though that there are tools out there that let us convert our files to an IFC file?
the only ones I know for sure QuickPen does it. QuickPen does it. They have what do they call it? It's called Design Link or something like that. It's an add-on, I think, to their product. I don't know if FabNet does it, but the only one I've seen so far is truly that works pretty well is QuickPen.
You've seen that?
Yeah, I've seen it. I've had IFC's files come back to me and they were able to open. I was able to look at them in Solibri, no problem. Everything seemed to be where so it snapped in okay.
The other way to look at it is to pester your vendors for that capability. It's how IFC has actually been embraced by others. We've been pestering them for the last 15 years. Dragging their feet, and they did something, and other groups did something, other groups pushed. So you reach out to the vendors of the product you're using and keep asking for it.
Right now we're locked in like sort of a Navisworks world, because everything sort of combines there, which is fine, and it works. But to make that bridge where we can both sort of be on the same thing and not bring it into another window.
Yep.
And, you know what I'm saying? Is that other window is sort of like another step that we don't want to take.
Yep. Navisworks is another file format you got to deal with and keep up to date. So it's definitely an issue. I mean, IFC in theory can solve this. It's just a matter of can the vendors attach to it. And I'm not saying it's perfect. There's a lot of things missing from 2x3, which is the current version out there, especially in the MEP side. There's a lot less categories than there really should be. I know IFC 4 addresses that, but again, that's now at a release candidate, so that's beyond beta. But I don't think any vendors are going to do it until it's like, all right, button pressed. This is now the standard. Geometry trim. That's what I was showing you earlier, the very first one. That's the only one I can write an IFC 4 file that I've seen so far, and it comes with a lot of caveats. Be careful with it because the standard's not set. So in the future, I can see this stuff happening. But right now, there's very few tools that actually do it. But I think asking, fabrication contractors to use Revit is a mistake. I don't think you're ever going to get there. Revit won't get there, as I'm saying. And it's silly to have, and it's really silly to have mechanical engineers updating stuff based on shop drawings that, coming this way. It's a lot. It's always the as-built that's the problem. It's always the as-built. That technically is a deliverable right at the end of the day.
Before we wrap up for the night, any last questions?
Thanks for hanging out. I know this went really late.
Let's check online questions real quick. Did we lose it? No. Nope, no questions. Okay. Thank you, everybody.
Thanks,
Take care.
guys.